So we're going to take what we've learned about accumulation and apply it to our particle motion. So we did particle motion already this year from a derivative perspective, velocity, acceleration, all that stuff. We're now going to do it from an integration perspective. All the vocabulary still means the same thing. All right, we're going to add some more vocabulary. Displacement is your integral from A to B of your velocity function. This is what we did last time. Just instead of calling it a rate, we're calling it velocity. Do you remember the gopher and the monkey problem? That's the one I bring up a lot, right? Do you remember how we had their rates of change? The rate is what goes inside of the integral. It's not different. We just called it velocity, okay? Now, if I'm standing here and I ran down the hallway and came back, I'm not going to do that. Just use your imagination. And I ended up where I started. What was my displacement? I did not get displaced, okay? But my actual distance was whatever that is, okay? So if you want to do total distance, it's going to look almost the same, but what do you need to put around your velocity? You're going to treat it all like it's positive so that my distance there is positive, or my accumulation there is positive, my accumulation back is negative. That's why the displacement would be 0. But if you treat it all like it's positive, it's going to add it all up, and then you get a total distance traveled, right? Yes, because the absolute value of velocity is speed. Yes. Kind of like in your car, you have a speedometer, you don't have a velocityometer. When you go in reverse, your speedometer still goes positive. Okay. Position. You take your initial condition plus your displacement. And we did that last time too. Remember the monkey started out 10 feet up in the tree and the gopher started out where? Yeah, like -10. Those were their initial conditions. And then we added their displacement, and that gives you their position of where they ended up. You also did it in your delta math. Remember, you took the initial condition and then you added on your accumulated area. So we did this last time. We're just using new vocabulary. Go ahead. Sorry. Oh, okay. Yeah, it's exactly like what you did. It's not new. We're just using words like velocity and acceleration and total distance and displacement. It's the exact same stuff. It's not new. Okay. So we're going to use this graph over here. It is a graph of what? Velocity. Typically, they give you a first derivative. That is the one that gives you all the information, your sticky note and stuff. Okay. So typically, they give you velocity. As a heads up, we're going to need all our areas. So let's just go ahead and find them now. Our first shape is a semicircle. That is going to be 1/2 pi r squared. All right. And what is the radius of that semicircle? 2. 2 squared is 4. Half that is 2. So 2 pi. All right. Then we've got this big old triangle. A triangle is 1/2 base times height. So the base is at 6. Cool. And the height is, I'm going to just put 6. The result is going to be negative because it's below sea level. It's a de-accumulation. Would that be -18? I just don't like to put negatives in my formula. That's a personal preference. That's like a me thing. All right. And then this last little triangle, again, 1/2 base times height. What is that going to be? 1.5, 1.5, or 3/2 if you're a fraction purist. So we're going to use that to answer all the questions. Just make sure you read. Find the total distance traveled. Now, they didn't give units, but it would be like in feet or meters or yards or whatever, by the particle over the interval 0 to 11. You're simply going to add all that up, but treat it all like it's positive. Total distance is going to be treated all like it's positive. So it'll be 2 pi plus 18 plus 1.5, so 19.5. Cool. Inches or whatever. They just didn't give units, but it would be some sort of distance unit. All right, find the value of this thing and explain what it means in the context of the problem. That means you're going to do the displacement. So you're going to add it all together, but you are going to treat the 18 like it's negative. So it's going to be 2 pi minus 16.5. Good. You have minus 18, but then plus 1.5. You're going to use the word displacement when you explain what it means. So you're going to say this is displacement. You're just going to use your vocabulary. They're going to ask you for either displacement or total distance. This is displacement in units. I'm putting that because on the AP exam, they're going to give you something. It would be like in yards, and then you have to say one other thing. What else do I have to explain about this? Boundaries. From 0 to 11, I'm just going to put units. It would be from 0 to 11 minutes or seconds or years or millennia, whatever your time measurement is. Displacement in whatever units from 0 to 11, whatever units. All right, if the initial position of the particle at time 0, but time doesn't always start at 0, it can start wherever they tell you, is 2, find the position at time 11. So you're going to take your 2 and you're going to add your displacement from 0 to 11. We already found that in the previous problem. All right. What did we find that this displacement is? 2 pi minus 16.5. So if you take that and just add on the initial condition, it's going to be 2 pi minus 14.5. So you just took what we had right here and added 2 is all that is. All right, I am going to do a lot of clicking back and forth to share my calculator on this one, so you're going to have to bear with me on that. The rate of change. All right, that's a rate. So it is what? Derivative or velocity, okay? In kilometers per hour. Something per something else means derivative. Rate, slope, all those good things. The altitude of a hot air balloon is given by this thing. 4 times 0 to 4. Time is in hours. So we have kilometers and we have hours. Assume the balloon is initially where? So that means 0. The balloon has to be on the ground or we can't get in. Do you get what I'm saying? Okay, I'm going to start by sharing my screen and we're just going to take a peek at this. All right, you're going to just have to bear with me and follow along because every time I switch, I have to hit share screen or it won't show up on my video. Okay. Although you're all present today, so I don't know that anyone's really going to be watching this video. I'm pretty sure, you know what, let me test this. I'm pretty sure if I do T, the graph isn't going to show up. I can't remember or not yet. Oh, it is showing up. Never mind, I was wrong. T, okay, well, I put R of T. T cubed minus 4T squared plus 6. Okay, cool, it did show up. Nice, I'm happy about that. All right, now I'm going to come over here to the little gear. And what did they say the window was that I want to change this to? Because right now it's negative 10 to 10. Wasn't it 0 to 4? Yeah, for the root question, like that initial part is 0 to 4. So I'm going to make it be 0 to 4. Okay. Now hold on. Let's discuss this for a second. Because the first thing everybody always tells me is when I'm like, hey, where's the balloon? They're like, oh, up there. No, the balloon is on the ground. This is not position. This is, okay, so let's talk about what happens. Balloon starts on the ground. See all this positive accumulation? That means the balloon goes, it can't start on the ground and then go down. Hot air balloons can't burrow into the ground. Let's go first. Okay? So the balloon goes up. Then the balloon goes down for all this negative accumulation. And then the balloon goes up again. Should you exit the ride at time 4? No. It's not advisable. Okay? Because the balloon is not on the ground. It is up in the air. All right, so that's what's going on. So can you guys all read letter A? My voice is showing up on this, so we're just going to do this verbally so I don't have to keep going back and forth with the calculator. When, so there should be a time, is the balloon closest to the ground? That means a minimum on the time interval 2 to 4. The reason they say 2 to 4 is because the actual minimum is 0. Okay, but we want a different minimum. Go ahead. This is calculator. We're gonna get there, yeah. Yeah, you're mentally ahead of me, so just hold on. All right. So closest to the ground means minimum. That is where your derivative, which is what you're looking at, changes from what to what? Perfect. Negative to positive. Do you see a place where this graph changes from below to above? Yeah, now it looks about 3.5, but it's not exactly. All right, that's the time you want to write on your paper. T equals 3.514. And then what was our time unit? Hours. Okay. Now this is going to be annoying because I have to keep going back and forth with my screen here, but I'm going to stop share and you can see what I wrote. All right. Time is 3.514 hours. Now follow-up question. What is the altitude of the balloon at that time? What am I going to set up now to do that? Integral from when to when? Yeah, 0 to that number. R of t dt. Your rate is always what goes inside of the integral. Now you want to type as many of the decimal points as you can so that it will be accurate enough. All right. So I'm going to do integral 0 to, now hold on, let me find this again over here. What was it? I see your hand. Hold on. Let me finish typing it. 3.51414. And then R of t dt. Cool. It actually worked. 1.348 what? Kilometers. Go ahead.
So my question is, so you're saying like how we need to put it in decimals. So when they're grading it, are they how specific do they?
You have to be accurate to 3 decimal points for your final answer. So here's the thing. If you only, now this one might work, okay? But if I only put this, that's 1.34. See, this one's accurate enough. But sometimes if you don't put enough of the decimal points, that final answer will only be accurate to 2, and then the third one will be wrong, and then they will not give it to you. All right, so I don't have to keep going back and forth. Let's just do this verbally. Read B for me. It says, when is the balloon what? Maximum. All right, that would be where we have a change from positive to negative. That would be right about here. 1.571 what? Hours. Go ahead and write that on your paper. 1.571 hours. Here, I guess I can show you my paper at the same time, but it just kind of like covers up the graph. So I can't have 2 screens up there at once. So all right, and then the follow-up is the exact same thing. What is the altitude at that time? Well, what am I going to do? Yeah, 0 to, oh geez, what was it? 1.57199. 1.57199 R of t dt. There we go. 5.779 what? Kilometers. 5.779 kilometers. And if there had been an initial condition, like if the balloon didn't start at ground level, like pretend it started half a kilometer up in the air, you understand you would have 1/2 plus integral, blah, blah, blah. Okay, it's just it started at 0. So, I mean, I guess you could put 0 plus whatever to remind yourself, but it was 0. So, cool. It's going well. Find the value of that and explain what it means. Okay, so let me share my screen again. I have this practically in there already. What am I going to do on my integral to change it? Like, what do I just need to change here? Yeah, I need to just change that to 4. Cool. It came out to, let's not truncate. Let's round that one. So that it can be 2.667. Just so it's not 2.666, all right? 2.667. And now we're going to explain what it means. Which vocabulary word are we going to use? All right, so we're going to say this. Your explanations are the same every time. Like, this is displacement in kilometers. Then you have to say one other thing. Yeah, from 0 to 4 hours. Just make sure you read what the units are. It would be a sad day if you accidentally put miles instead of kilometers or seconds instead of hours. It'll be wrong, you know, so just be careful. I would not, because an arrow indicates a limit, and that's a different note. That means something else mathematically. Okay? Yeah, don't put a dash. That means subtraction. That's fine. Yes. No, he was asking about in the sentence. Okay. Now, before I switch back so that I don't have to keep going back and forth, let's write our sentence first for this one. You can actually get the sentence before you even do the problem. It's actually going to be the exact same sentence, except we're going to say this is what? What distance? Total distance. Good. This is total distance. Yep. Oh, no. Don't do that. Sorry. You can abbreviate distance, D-I-S-T, probably. You can get away with that. TD does not mean anything mathematically. That means touchdown. That's not a thing. All right. This is total distance in kilometers. from 0 to 11 hours. Weren't you told last year not to abbreviate anything at all? Oh, what did I put? Oh, that would be wrong. Guess how many points they would give me for that?
0.
None at all. You can know exactly what you're doing. Do you know why I put 11? The previous problem had an 11 in it.
Also, wouldn't this be like a type of problem?
Yes, you'd have 1 point for the numeric answer and 1 for the sentence. But for the sentence, I would lose the whole point. There are no half points. Yeah, like there are, I don't have anything else to say about that. There are no half points. You either earn a point or fail to earn a point. And if there's any part of that that's wrong, you fail to earn the point. Okay. I've been asked often why I'm not an AP grader. They're like, Ms. Cole, you know so much about the exam. Yeah, but I'm not evil. Like, I can't do it. Like, I just couldn't do it. I would be like, oh, you know what you were doing. And then I would get fired and that would not be good. All right. So all I need to do is highlight this R of T and then put an absolute value in there. Do you guys know where the absolute value is? Or, oh, yeah, you can do it that way. But see, I kind of want to get the whole thing at once. So I just kind of highlighted it and I'm doing that. There's a lot of different ways you can do stuff. Do you see how that's a bigger number? That should make sense. All right. 11, I'm going to read it because I know it came out kind of small. 11.528. And you don't actually need to write kilometers next to that. Do you know why? The reason we don't need to put kilometers right there is because we put kilometers there in our sentence. And you don't need to put it twice. As long as you put it once, then you're good. All right, I don't need my calculator anymore, so I can quit skipping back and forth. All right, I found this problem somewhere, but I changed the units because I got so tired of doing like miles per hour and feet per second. So can you read this one and look at what I made it? I made it nanometers per decade, just to keep you on your toes. Okay.
That's pretty much immeasurable.
I was just trying to be silly. All right. So let's go ahead and read the first one. Use a left Riemann sum to approximate this. All right. How many sub-intervals have we got? 3. Circle them. I hate to tell you this, and this does make me angry as well, because you're going to take the exam on the computer. You can't draw on your computer screen when you're taking it. And it would help so much if you could like circle those things. All right. Unfortunately, and you know, when we did the accumulation function, you know how you want to slice up all the areas on your graph and draw? You can't interact with the graph because it's on a screen and it would take forever to draw it on paper. Just letting you know, these are frustrations. All right. Are we using velocity or acceleration for this one? Velocity. All right. So what is the length of your first sub-interval? 2. We want the number on the left, which is 5. Good job. All right, next one. From 2 to 6 is 4. We want the number on the left, 3. Cool. One more. It will be from 6 to 10 is 4. Number on the left, -1. What do you do to that? Nothing. All right. But we do have to explain what it means. What vocabulary word is this one? Good. This is displacement. Are you guys getting that this is the 3rd time I'm having you write the same sentence? It's because that's the answer on your AP exam. I can't change it. It's a vocabulary word. It just is by definition the answer. This is displacement in nanometers from, I think that is the abbreviation for nanometers. So that is okay. You can abbreviate units. All right, from 0 to 10 decades. Right, or glacier. So, you know, it isn't, and they'll accept this, okay? It technically isn't the displacement. It is an approximation for the displacement. You get it's an approximation, right? Because we don't have an actual function to work with. Remember Riemann sums, the little rectangles underneath? Approximation. All right, is that approximation greater than or less than the actual value? Here's what you want to look at. 5, 3, -1, -8. What is happening to those numbers? Okay, just look visually. This is something that's going down. This is the left. This is the right. Did we do a left or a right? A left. Above or below? Do you see how it's higher up? Okay, so we're going to say greater, or you could say over approximation. I just said greater because that's the word that's in this sentence. Greater because this is I'm going to say that. You can say it in whatever order you want. This is a left sum and velocity is decreasing. If you say it is decreasing, they will not give it to you. And I'm actually on their side on that one because velocity is not the only thing in this problem. What else is in that table? Yeah, and you need to say which one you mean. So I actually am kind of on their side with that. No pronouns, all right? Don't say it. All right, use a trapezoidal sum to approximate this thing. Let's see who remembers how to do a trapezoid. What's first in the formula? Good, a half. What's the length of your first subinterval? 2. And then you add the bases together. We're still using velocity. So 5 plus 3. Nice. Now we're just going to do it again. A bracket and a parenthesis are really the same thing, so it's up to you, it's personal preference. I'm going to do them separate. Actually, you kind of have to, well, personal preference, how you want to write it. I'm going to just do 3. There's only 3, so I'm going to just do them separate, right? 1/2, and then what is the length of your second subinterval? 4. Add the bases together. It's actually 3 plus 1. Why is it a positive 1? It's an absolute value. Okay, one more. Plus 1/2. Length of the last subinterval is 4, and then add the positive bases together. 1 plus 8. Don't put 9. I feel like I heard somebody say that. Oftentimes they will say, show the computations that lead to your answer, and that is 1 plus 8. Okay, so don't do it in your head. Write out all of the things.
It does show like absolute value out here, but I thought you would have to first solve everything in the
No, you're doing, I don't want to say absolute value in, because that's probably not the right way to say that. You're doing the absolute value of the velocity and then putting it into the formula. It's just the other way around. You absolute value these numbers of velocity, and then you input them into your formula. I understand what you're saying. Hey, can't we leave this negative and then just throw an absolute value around the whole thing? That it doesn't work that way. You have to absolute value those numbers and then put them in the formula. Okay, good. I'm glad, because I was hoping that was a good enough explanation. All right, do they want anything else from us here? What is this? Explain what it means. This is what? Perfect. This is total distance. If you want to abbreviate distance, you can do that. This is total distance in, I already started writing the whole word, in nanometers from 0 to 10 decades. I made you write those sentences 3 times just to like hammer that in. When you get that on your AP exam, that is the answer. The only thing that's going to change is the units, the nanometers and the decades. It'll be something else, right? Sure, correct. It's usually, well, people get so used to feet and seconds that then they'll put feet and seconds even if that's not what it is. So I was trying to get people to actually read the problem. That was my purpose in that, all right? This one's a little tricky because it makes you feel like you're going to use acceleration. But we are going to do an antiderivative. If you do an antiderivative acceleration, that takes you backwards to velocity such that 0 to 10, okay? Hey, Ms. Cole, why is that one different? Let's read. Do you see how this one says approximate? All right, we're using a sum, a trapezoidal sum. This one says approximate. This one says approximate. That's what your sums are. Does this one say approximate? No, we want the real, actual, true value that is not an approximation. So I can't do any kind of sum. Your left, right, midpoint, and trapezoidal sums, those are approximations. I want an actual answer. So we did an antiderivative. Oh, and what do we call this? What theorem is this? The fundamental theorem of calculus. Cool. And then we're going to do upper minus lower. So V of 10. No. No, not how that works. I also like the fundamental theorem of calculus, but I'm not going to lie to you about what points you're going to get for it. All right, what was V of 10? Can we look back at the table? -8 minus, and then V of 0 is 5. Now let's think about what we actually did, because I think they want this in context as well. All right, we took the velocity at 10. That's whatever nanometers per decade. and we subtracted the velocity at 0, which is whatever nanometers per decade. So our units are nanometers per decade. It is the change in velocity. So it is how our velocity changed. It's the change in velocity in nanometers per decade. Yes, good, perfect. I just can't write that fast. Change in velocity in nanometers per decade from 0 to 10 decades. Let me explain it again. I almost ran out of room. You're taking the velocity you ended up with and you're subtracting the velocity you started with. If you take where you end up and subtract where you started with, that's the change. It's how much you changed by. It's kind of like if I took my height now and I subtracted my height when I was 9 years old, that's going to give me the change in my height from 9 years old to now. Do you get what I'm saying? It's change, okay? If you do a subtraction, it's change.